Hi everybody, here's a little introduction into how you can use Mrs. Baker's table method and a magic triangle to solve any question that Cambridge want to throw at you. So in the blast furnace, hematite, which has a formula Fe2O3, is converted into iron. The question is asking what mass of iron can be obtained from 16 tons of iron oxide. So for this, we are using the mass moles MR triangle because it's given us our mass in tons. Don't worry about the fact that it's in tons. It just means your answer will be in tons. We don't need to convert it. So let's put in what the question tells us. We follow this for this step-by-step method. It holds true for every single question that you get. The first thing you do is highlight what they've given you in the question. So 16 tons of iron oxide. We can always work out the relative molecular mass because we've got our periodic tables. So the relative molecular mass of iron is 56 times 2 because there are 2 ions, and you add that to 16 times 3 because there are 3 oxygens. That gives us, open our brackets, 56 times 2, close our brackets, plus, open our brackets again, 16 times 3, close our brackets again, gives us 160. So our mass is 160. To find, using the mass moles MR triangle, to find the moles, we do 16 divided by 160. That gives us 0.1 moles of iron oxide. Now we need to look at the molar ratio. So we've got 1 to 2 ratio. If I have 1 mole of iron oxide, I have 2 moles of iron, but I don't have 1 mole of iron oxide. I have 0.1 moles of iron oxide, but I've still got double the amount of iron than I have of iron oxide. I just use my simple molar ratio. So if I've got a 1 to 2, I've got a 0.1 times by 2 moles of iron. So I keep my calculator value, I just times it by 2. That gives me 0.2 moles of iron. Now I can work out the MR of iron. It's 56. A lot of people say, well, Mrs. Baker, why isn't it 2 times 56? The reason it's not 2 times 56 is because in this column here, we use the big numbers, the molar ratio. The big numbers tell us our molar ratios here. But the small number talks about the mass of the compound. And so the mass of the compound, we need to look at the small numbers going along. So this is small or subscript numbers in this one here, just like we did 56 times 2 because we had 2 lots of iron here. But we don't have 2 lots of iron here, we just have 1 iron. So it's 0.2 times 56 will give me my mass. So I've already got it on my calculator. I just times by 56. That will give me 11.2 tons. So in answer to the question, what mass of iron can be obtained from 16 tons of iron oxide? Well, that would be 11.2 tons. Hope that helps.